in these questions we have to make use of the formula from the formula sheet. So in 2a, f of r is sine 2r, therefore del f, which we're asked to find, is going to be df by dr times r hat. So df by dr by chain rule is going to be 2 cosine 2r. So let's write that down here. So f of r is sine 2r. That implies that df by dr is 2 cosine 2r, which in turn tells us that del f is going to be df by dr times r hat, so 2 cos 2r times r hat, which you see down here as the answer. Then del squared f is going to be del dot f of r, where f of r is what we just found. So we use this expression here to find del squared f. As we can see, it's indicated in the answer here, del dot del f. Well, del f was our f of r, which is this here, 2 cos 2r times r hat. So del squared f is going to be 1 upon r squared from this formula here, times d by dr of r squared times f of r. So our f of r is this 2 cos 2r. So because we've got a product there, we need to use the product rule. So the 1 upon r squared we can write down here, and then we need to apply a product rule. So that says the derivative of a product is the derivative of the derivative of a product of two functions. It's the derivative of the first function, so the derivative of r squared is 2r, times the second function, so times 2 cos 2r, plus the derivative of the second function, so that'll be minus 2 times 2 sine 2r, since the derivative of cosine is minus sine. So in fact that gives us minus 4 sine of 2r, and that's multiplied by the first function, which is r squared. So if we then multiply through by the 1 upon r squared, we'll see that we get the answer there, because we've got 4r here divided by r squared gives us the 4 upon r term times the cos 2r, so 4 upon r cos 2r, and then the r squared will cancel with this r squared, giving us the second term, minus 4 sine of 2r. So we've got two part A, and the others, well, part B will make use of an equivalent set of functions or formulae, but for cylindrically symmetric functions. So there are different formulas, you'll have to look those up. Question 5, and you'll recognise the relevant formula because they'll use a capital R rather than a lowercase r. Question 5, we're back to using these with small r. So we know, for example, in 5 part A what type of symmetry is involved? Well, since we've got three components, x, y, z, we know it's spherical because there are three components. So rewrite f in terms of an appropriate readable distance. We know r squared is x squared plus y squared plus z squared, so this in fact is r squared to the power 3 upon 2. So the power raised to another power, we multiply the powers, so 2 times 3 upon 2 is 3. So in fact that's why we get r cubed. That's the answer for part B. And then del f, as in 2a, is calculated using df by dr times r hat. And since f of r is r cubed, the derivative of that is obviously 3r squared. Del squared f we find again using this expression here, and we know that r squared times f of r is going to be r squared times r cubed, so r to the power 5. Derivative of that will be 5r to the power 4. Divide that by r squared, and our f of r is 3r squared, so it's going to be 3 times r to the power 4. Derivative of that will be 12r cubed. Divided by r squared, and we end up with 2r. That's the answer.